Alright, frame 8, continued with radicals. You might have to simplify, add, subtract, multiply, divide, or rationalize. If it is a perfect square, meaning you can square root it and it becomes a whole number, you try it on your calculator, the square root of 121 is 11. Otherwise, we're going to try to break it down into perfect squares. Find the factors that go into 80, maybe 4 and 20, which breaks down into 2 times 2, and 2 times 10, and 2 times 5. Well, because it's a square root, we need to take out pairs of numbers. You have a pair of 2's, you have another pair of 2's. 2 times 2 is 4. This square root of 5 is left over, so it stays in here. But please don't forget about this 2 all the way up there. 2 times 4 is 8. And 8 square root of 5 is your final answer. Same idea over here with 27. You cannot add these together if they're not like terms. Square root of 27 is not like the square root of 3. So we break that down into 9 times 3, which also breaks into 3 times 3. And now you have a pair of 3's. Since you have a pair of 3's, the square root of that is 3, square root of 3. Now it's like 5 square root of 3. So if you had 3 square roots of 3 and somebody else had 5 square roots of 3 and you put those all together, you would end up with 8 square roots of 3. Like terms needed to add and subtract. Here is a subtraction one. You have the square root of 72. Find 2 numbers that go into 72, like 8 and 9, or 6 and 12, or 2 and 36. Keep breaking them down into all of their factors until you find pairs. You've got a pair of 2's and a pair of 3's with a single 2 left over. 2 times 2 is 4, but we want the square root, so we only need the 2. 3 times 3 is 9, but we're looking for the square root of that, which means we need a 3. And it's always all multiplication. These are factors. Square root of 2 is left inside, which means you have 6 square roots of 6. Break down the 50 over here into maybe 25 times 2 and 5 times 5. What did I do here? Let me back up. I've got a 6 on the outside, but a 2 on the inside. Square root of 2. Now I have a pair of 5's. That's 5. You have a 2 left over. 5 square root of 2. Well, up here it said we wanted to subtract them. What is 6 square roots of 2 minus 5 square roots of 2? You get 1 single square root of 2. Notice I didn't put the 1 in front of it, just like you don't put a 1 in front of a variable. You just have plain old square root of 2. Let's try a multiply one. In the multiplication, you multiply the outside numbers. 2 times 3 is 6. Multiply the radicals. 12 times 4 is 48. If this breaks down, you still have to break it down. If it doesn't, you're done. 48 breaks into a lot of things. I'm going to use 4 and 12, 2 and 2, 2 and 6, 2 and 3. You have a pair of 2's, another pair of 2's, and a 3 left over. 2 times 2. And you have a square root of 3 left on the inside. 2 times 2 is 4, but don't forget the 6 that's been hanging out there. You have 24 square roots of 3. And lastly, you have to remember how to rationalize radicals. I'll move this down where we have some room. It is not okay to have a radical in a denominator. Against the mathematical rules. Best way to get rid of that is to multiply it times itself. Because the square root of 15 times the square root of 15 is just plain old 15. If you don't believe me, try it on a calculator. Take 15 squared and take the square root of it. Or it's the same as taking square root of 15 squared times itself. They cancel out. But now mathematically, the other rule is whatever you do to the denominator, you must also do to the numerator. So you have 3 square roots of 15 in the numerator. Notice again, a whole number stays out, square root of 15 stays in. 3/15 reduces as a fraction to 1/5. Therefore, your final answer is square root 15 over 5. You will have one of each kind of these on your final exam. End of chapter 8.